Good evening, everyone. It's great to have you with us. I'm Gillian, and I'll be leading tonight's session. Welcome to our GCSE revision session designed to give you that final edge before your chemistry exam tomorrow. We're here to equip you with practical strategies and essential insights to help you walk into your exam feeling confident and prepared. Tonight's session is all about effective study methods and last minute tips that will make a real difference. During the session, you can get your questions answered by posting your questions using the link in the chat. Okay, then, so this is our question for today's session. What do you need to do to prepare for your chemistry paper 2? So, this is what we are going to be focusing on this evening. So, breaking down our question for the session into our 3 learning outcomes, we are going to recall how best to tackle these different types of questions on chemistry paper 2. We are going to apply different exam strategies to answer past paper questions with clarity and with control. And we are going to regulate your mindset and approach using practical techniques to manage stress and to improve focus before and even during your exam. Okay, then, so let's get started. So, our first question is all about rate of reaction. And if you've joined us previously in our sessions, you may be familiar with bug. And there's a little bug in the top corner of my screen. So B stands for box. So we're boxing the command word. Okay. U is means underline. So we're underlining that key information in the question. And then G is glance. We are going to glance at the number of marks there. So let's do bug. Okay, so this question is about the reaction between sodium thiosulfate and hydrochloric acid. So our command word for this question that we boxed is explain. If you're given that explain command word, you should make something clear or state the reasons for something happening. Then what we need to do is we need to read the information in the question. We need to underline that key information. So this question is about the reaction between sodium thiosulfate and hydrochloric acid. And we have got our balanced symbol equation here for that chemical reaction. So the mass of the conical flask and contents was greater at the start of the reaction than at the end. And we just need to glance at the number of marks. So this is a 2-mark question. So we need to make 2 key points. Now, if we look at this equipment here, hopefully this is familiar to you. This is what we call a disappearing cross experiment. So what you would do is if you were doing this experiment in the lab, you've got your conical flask, you would add in a certain volume of sodium thiosulfate and hydrochloric acid, place your conical flask onto that cross, and you would time how long it takes for that cross to disappear, hence the name, the disappearing cross experiment. So looking at our balanced symbol equation here, you can actually see that this solution will actually go cloudy. Why does it go cloudy? Because it forms sulfur, which is a solid. It forms what we call a precipitate. So a precipitate is an insoluble solid that is formed by a reaction. So sodium thiosulfate and hydrochloric acid are our reactants. And in this chemical reaction, we are making sodium chloride, water, sulfur dioxide, and of course that precipitate, which is sulfur. And this sulfur forms this cloudy yellow-white precipitate during the reaction. So the time taken for this to happen, for our solution to go cloudy, gives us a way that we can measure the rate of reaction. So, but what is this question actually asking us then? So the mass of the conical flask and contents was greater at the start of the reaction than at the end. Why? Now, this question not only is about rate of reaction, but it's also about the law of conservation of mass. All chemical reactions obey this law, and it states that in a reaction, the total mass of reactants must equal the total mass of the products. And you may notice that on our balanced symbol equation here, we have got these state symbols in brackets. So AQ is aqueous, so it means that it's in solution. Okay. L means it is a liquid, and G means that it is a gas, and obviously S is solid. If you are asked to write a state symbol as an answer to an exam question, make sure you have brackets around that state symbol. So we're thinking about, well, why is the mass of the conical flask and content greater at the start of the reaction than at the end? Well, because it is an explain question, we have to be very careful that we explain our answers if we are asked to. And what we can see here is, you can see on my little conical flask, there are bubbles of gas which are escaping. And sulfur dioxide gas is produced, which escapes from the conical flask. So we have to say 2 marking points for that. So sulfur dioxide gas is produced, and it escapes from the conical flask. Okay, so let's move on to our next question, still on the same experiment. So for this one, my top tip is make sure that you understand your key words. So a student investigates the effect of concentration on the rate of reaction between sodium thiosulfate and hydrochloric acid. We need to name the independent and dependent variables. You need to know what those two keywords mean. So, independent variable in an experiment is the variable that we change, and the dependent variable in our experiment is the variable that we measure. So we need to be thinking about, well, in this experiment, what are we changing and what are we measuring with? Remember to make sure we have got a valid method. We just need to change one variable, and we are measuring one variable. And then all the other variables that may affect our experiment, we need to keep the same, and we call those the control variables. So what are we changing in the experiment? Well, in students investigates the effect of concentration on the rate of reaction. Well, of course, then, so we are changing the concentration of the sodium thiosulfate solution. So what are we measuring then? Well, we're measuring the rate of reaction, and we're actually measuring, remember, we're measuring the time taken for that cross to disappear, for that cross to no longer be seen. Okay, then, so moving on to our next question. You could be asked to plot a graph tomorrow in your exam. My top tip for you is obviously make sure you've got your equipment, you've got a pencil, ruler, eraser, pencil sharpener. Take care with drawing points on graphs and curves of best fit. So you can see we've got table 1 shows the students' results. We need to plot the data from table 1. Okay, and we need to draw a line of best fit. And we can see that this is a 3-mark question. So I've got a table of results. So this is obviously the independent variable. So this is the concentration of sodium thiosulfate in moles per decimeter cubed, and then the time in seconds for that cross to disappear. Now, on this exam question, you can see that they provided you with some graph paper. And actually, they've already provided you with a scale on the X and Y axis, but make sure if you are having to draw a scale, make sure that your numbers are equally spaced. So, for example, going up in 0.1 or going up in tens. And another exam tip is try to use as much of that graph paper that they give you in that exam. So, let's plot our first point. So the concentration of sodium thiosulfate is 0.1. The time in seconds is 82. So go across 0.1, go up to 82, and then you can draw a dot or a cross and plot your points. Okay, so here are my points that I have plotted. And what we need to do next is, so we've plotted our points. If you've got time, check that you have plotted your points correctly. And what we need to do is we need to draw a smooth curve of best fit. Remember, in science, a line of best fit can obviously be a straight line, but it can also be a smooth curve. Make sure it's smooth. Make sure you've got no like hairy lines on there. So a nice smooth curve of best fit. Okay, so there is our graph for that experiment. So the next question, we need to use your graph to predict the time taken for that cross to no longer be seen at a concentration of 0.7 moles per decimeter cubed. But our concentration only goes to zero point 0.6. So what we need to do is we need to continue our line of best fit to 0.7. And then what we need to do is we need to read off the graph at concentration 0 0.7, what is the time taken. So it's so important that you make sure that you've got a ruler in your exam tomorrow. Okay, so you can draw a nice straight line and you've got a pencil as well. So drawing that line across, we go. I'm going to read the time taken off the scale there. So you can see that 0 0.7 moles per decimeter cubed, it actually takes 7 seconds for that cross to disappear. And what I can even do is, just to make it really clear, I can add that result onto my results table. So don't forget, you could be asked to plot a graph tomorrow. So next question. What is the relationship between the concentration of sodium thiosulfate and the rate of reaction? So looking at our results table, what's the relationship between these two variables here? So as I'm increasing the concentration of sodium thiosulfate, what is actually happening to the time taken for that cross to disappear? And as you can see, as the concentration increases, the time taken for the cross to disappear also decreases, which means that the reaction is happening at a faster rate. So as the concentration of sodium thiosulfate increases, the rate of reaction also increases. And again, just be mindful, it's only 1 mark. We're just being asked about the relationship between those two variables. Now, next question. I'm going to go into this in a little bit deeper now. So increasing the concentration of sodium thiosulfate increases the rate of reaction. We need to explain, there's that command word again, explain this relationship in terms of collision theory. Now, this is a 3-mark question. So I need to make 3 points about collision theory. Now, what is collision theory? I'll be thinking now, what is collision theory? Remember, for any chemical reaction to happen, reacting particles must collide with each other, and the particles must have enough energy for them to react. And that minimum amount of energy required for a chemical reaction to take place is called the activation energy. Okay, so what is my top tip then for this question? Well, for these 2 to 4-mark questions, remember it's 1 mark per point. So obviously this question is 3 marks. We need to make 3 points. So that's also key as well. So at higher concentration, there are more particles present per unit volume. So there's more particles present in that volume of sodium thiosulfate when we are increasing the concentration. So if there are more of them per unit volume, it means that these particles are closer together. So if these particles are closer together, you are going to be increasing the frequency of collisions. So make sure you are really familiar with collision theory. Okay, next question. We have got a calculation question now. You could be asked to calculate the rate of reaction. Now, If you have joined us previously, you will be very familiar with FIFA, okay? So my top tip for this question is use FIFA to answer these calculation questions. So formula, insert numbers, fine tune, and then answer. So in one experiment, we've got 0.725 grams of sulfur is produced in 20 seconds. We need to calculate the mean rate of reaction from 0 to 20 seconds. Use this equation. Now, if they don't give you the equation, another tip is I would learn that equation. So it's the mass of reactants. So the mass of product, even just testing you there, it's the mass of product produced in grams divided by the time in seconds. So I've produced 0.725 grams of sulfur in 20 seconds. So I write down the formula. I insert my numbers. So it will be 0.725 divided by 20. I don't need to fine tune anything. I don't need to do any unit conversions. So on your calculator, another tip, please make sure you've got your calculator for tomorrow. The mean rate of reaction is 0.03625. But what are my units for this? Well, the mass of sulfur is in grams and the time taken is measured in seconds. So my mean rate of reaction is grams per second. Okay, so moving on again, let's have a look at another calculation that you could be asked to do tomorrow. So this time, the student did the experiment with 0.15 moles per decimeter cubed of sodium thiosulfate solution and repeated the experiment 3 more times. So there's our test 1, 2, 3, 4, and this is our time. We need to calculate the mean time for this reaction. Do not include the anomalous result in your calculation. So an anomalous result is a result that does not fit the pattern, and we have to give our answer to 3 significant figures. So another tip, when you're doing any kind of calculations, always show your full workings out. Never just write down the answer. Just in case you make a mistake on your calculator, always show your full workings out. So I need to identify that anomalous result. Clearly, it is 82.3 because it doesn't fit in with those other readings there. So I can ignore that result, okay, because we don't need that when we're calculating the mean. To calculate the mean, I would need to add all of the other readings together and then divide by how many I've got. So I did 3 tests there. So doing our calculation on your calculator, don't forget to press equals before you divide by 3. And I get this as my answer, but I need to give my answer to 3 significant figures. So what you would need to do with this, so this is our answer. We can see that the first 3 digits, let me just get rid of that there. So the first 3 digits are 6, 3, and 1. And then we need to look at this 4th digit and we need to decide if we're going to round up or we're going to round down. So that 4th digit we can see is 3. And because it's obviously less than 5, we need to round down. So this answer here becomes 63.1 seconds. Remember, 2, 3 significant figures. Okay, so a lot of calculations there just to finish off with. So let's review our top tips for our first question. So make sure you understand keywords. Take care with drawing points on graphs and curves of best fit. For 2 to 4 mark questions, it's 1 mark per point. So for 3 marks, you need to make 3 points. Use FIFA to answer calculation questions and always take care with calculations and always show you're working out. Okay, so moving on, we are going to go to question 2. Question 2 is all about chromatography, and we have got a multiple choice question here. Remember, chromatography is used to separate mixtures, and it's also used to identify substances as well. So my top tip for this one is to read all options in multiple choice carefully, even use like a process of elimination to get rid of that incorrect answer that you think, well, it can't possibly be that. So let's using our book. So what is the name given to a mixture that has been designed as a useful product? So we need to tick one box because it is a 1 mark question. So let's have a look at our options. So we've got fraction. So fraction is a word that you should know from the organic chemistry units, and it is to do with fractional distillation. And a fraction is just different parts of the original mixture of crude oil called fractions, and the substances in each fraction have got similar boiling points to each other. So let's rule out fraction because it can't possibly be that. Our next one, formulation. What is a formulation? Well, a formulation can be, for example, it can be paints, for example, medicines, and a formulation is a mixture that has been designed as a useful product. So we know that it's formulation, so then it can't be formula. Okay, next question. So chromatography is a separation technique that we use to separate mixtures. Chromatography involves a mobile phase and a stationary phase. So, why do the substances in the mixture separate in the mobile phase? Okay, so boxing our command word, underlining the key information in the question, and then glancing at the mark scheme. So, this is just a one mark question here, not the mark scheme, the number of marks for the question. You know what I mean. So, we use chromatography. Now, it actually does rely on these 2 phases here. So the mobile phase is basically the solvent, so that moves through the chromatography paper, and the stationary phase is contained on the paper. So these 2 phases, but our question is asking us, why do the substances in the mixture separate in the mobile phase? Well, the different dissolved substances in a mixture, they are attracted to the 2 phases in different proportions, and this causes them to move at different rates through the paper. So, for 1 mark, our final answer is it's just because the substances move at different speeds in the mobile phase, and that's why the mixture separates. Okay, still with chromatography, let's look at this question here. So, chromatography is used to separate mixtures. A student used chromatography to investigate the colours in black ink. The student used a ruler for the start line. What would the student have used to draw the start line? Give one reason for your answer. So using our book, so give, underlining that key information in that question, and noticing as well, glancing at the number of marks, there's 2 marks. So we need to state, well, what would the student use to draw the start line? Would they use a pen? Would they use a pencil? But then we need to give a reason for their answer. Okay, so if you've done any chromatography experiments, you know that we would always use a pencil to draw the start line on the chromatography paper. But why would we use a pencil? Why can't we use a pen? Well, we are using chromatography to investigate the colours in black ink. If we used a black pen to draw a start line, that start line will dissolve in the solvents. The reason why we use pencil to draw our start line is it does not dissolve in the solvent. So always remember, anything to do with chromatography, anything to do with the chromatography practical, you would always draw your start line using a pencil. Next question. So in a chromatography experiment, a blue colour moved 4 centimetres. The solvent moved 5.5 centimetres. Calculate the RF value of the blue colour. Again, we've got FIFA. Think about your favourite football team if this is going to help you. Again, use FIFA to answer these exam questions. So we've got a blue colour that has moved 4 centimetres, and the solvent has moved 5.5 centimeters. We need to calculate this RF value of the blue colour. So this RF value is the retention factor. It's the ratio of the distance moved by a compound to the distance moved by the solvent. And these RF values, they can be used to identify unknown chemicals if they can be compared to a range of reference substances. And my another top tip I'm just going to throw in there, I would learn this equation. Write it down, make a note of it, because you could be asked to calculate the RF value tomorrow. Make sure you learn that equation. So it's the distance moved by the substance divided by the distance moved by the solvent. And when you do a chromatography experiment, you get this chromatogram. And I'm going to give you another top tip. Now, this question, they've given you the distances. You might be asked to measure these distances tomorrow from a chromatogram diagram. Now, my tip is when you are doing this, you always measure from the baseline, okay, obviously to the what we call the solvent front. So this is the distance moved by the solvent, but when you're measuring the distance moved by the substance, remember you are measuring to the middle, the center of that spot, okay? So make sure again you've got your ruler tomorrow. So this is our equation. We just need to insert our numbers. So 4 divided by 5.5, because 4 centimeters is the distance moved by the blue color, and 5.5 centimeters is the distance moved by the solvent. We don't need to fine tune anything. We don't need to do any unit conversions. And our answer is 0.73. And there are no units for the RF value. Okay, so that is another calculation question. Now, chromatography is a required practical, so is rates of reaction. Please make sure that you are familiar with the required practicals that you could be asked about on paper too. So this question is about the chromatography required practical. So black ink is a mixture of several colours. We need to plan an experiment using paper chromatography to separate the colours in the black ink, also to identify the colours from their RF values. And this is a 6-mark question. So when you're answering these kinds of method questions, you want a logical order that someone could follow to carry out the experiment to achieve a valid outcome. And when you are describing methods, my top tip is to write short, clear sentences when describing methods. Now, if I was actually answering this question, what I would do personally is I would draw a diagram to help me write my methods. So I would draw my chromatography paper. I'm going to have my baseline drawing pencil. I'm going to have my black ink. Okay. I'm going to secure my chromatography paper. I'm going to wrap it around a wooden splint. There we go. And I'm going to then place that in a glass beaker, which will contain a small amount of the solvent, which is water, making sure that it is below the baseline. Now, to help me, I am going to label my diagram. Okay, so I'm just going to put these labels on here. So that's my black spot with the ink. So this is my wooden splint to secure my chromatography paper. I will use for this, we just use a small glass beaker. I have my solvent, which in this experiment is water. And then I have got my chromatography paper. I am checking my spellings, as you can see. My chromatography paper. There we go. And then I have got in the middle, my small dot of black ink. Okay, so my small dot of black ink. There we go. So I've got a diagram. Now I'm thinking, great, I can write my method now. So what would my method look like? Okay, so draw a pencil line near the bottom edge of the chromatography paper. Place a small dot of black ink on the pencil line. Pour a small volume of water, which is the solvent, in the beaker. Put the bottom of the paper in the water, making sure that the start line is above the water solvent. Leave to allow the solvent to rise through the paper. When the solvent gets near the top of the paper, remove and leave to dry. Determine the RF value. So think back to that calculation that we've done previously. So take those measurements from your chromatogram and compare with known RF values. Okay, so that would get you 6 marks if you are asked about the chromatography required practical. Now, I have mentioned this before, but I am going to come back to this because I do think this is really, really important. If you are not sure about the required practicals for your exam board, do you know what I would do? I will go on YouTube, find a little video clip, and make sure that you are familiar with the equipment used and the method. Now, I have mentioned already the rates of reaction and the chromatography required practical. There is also a required practical on water purification as well. So for paper 2, there are 3 required practicals. So to sum up, what are our question 2 top tips? Read all options in multiple choice carefully. Write in short, clear sentences when describing methods. Use FIFA to answer calculation questions, and don't forget to box, underline, glance, use bug to help you answer these exam questions. Okay, so I don't know about you, but after doing a required practical 6 mark method question, I like to do a little relaxation technique. And this technique is used to help quiet your mind and relieve stress. You can do this before the exam. You can do this during the exam. Okay, so what we would do here, we would start here and we would breathe in for 1, 2, 3. We would then hold for 1, 2, 3, and then we will breathe out for 1, 2, 3. So you can do this at any time during the exam. Helps quiet your mind and to relieve any stress. Okay, so let's move on and let's have a look at our final question. So this final question is all about the Earth's atmosphere. So the percentage of carbon dioxide in the atmosphere has actually decreased since the Earth's early atmosphere. Which 2 processes have decreased the percentage of carbon dioxide in the Earth's atmosphere? And it's a 2 mark question, and we need to tick 2 boxes. So we've got some processes here. We've got the combustion of fuels, the formation of sedimentary rocks and fossil fuels, photosynthesis, and volcanic activity. So which 2 of these processes have decreased the percentage of carbon dioxide? Well, let's eliminate the ones that we know are definitely not correct. So again, top tip for this question, and we've had this top tip before, haven't we? Read all options in multiple choice carefully. So I know the combustion of fuels and volcanic activity actually increases the carbon dioxide levels. So it's the formation of sedimentary rocks and fossil fuels and photosynthesis, which plants carry out, which have actually decreased the levels of carbon dioxide in the atmosphere. So moving on to our next question, the total amount of carbon dioxide emitted over the life cycle of a product can be measured. What is the name given to the total amount of carbon dioxide emitted during the life cycle of a product? We need to tick one box. And this is a 1 mark question because obviously we just have to tick one box. So our answers are carbon footprint, global dimming, or the greenhouse effect. So remember, another top tip, even if you are unsure of the correct answer, remove the incorrect option so that can help you make a better decision. So you actually need to know what all of these keywords mean. So let's start at the bottom because we can. So the greenhouse effect is the increase in the temperature of the Earth's atmosphere due to those greenhouse gases in the atmosphere trapping infrared radiation from the surface. So it can't be the greenhouse effect. So, okay, what's global dimming then? Well, global dimming is the gradual reduction in the amount of light reaching the Earth's surface. And this can actually be caused by carbon particulates, so soot, which is produced during incomplete combustion. So it can't be global dimming. So, of course, the correct answer is carbon footprint. So the carbon footprint is the total amount of carbon dioxide emitted during the life cycle of a product. Okay, so moving on. Another multiple choice question. Top tip again, read all options on multiple choice carefully. Carbon dioxide is a greenhouse gas. Which of the following are also a greenhouse gas? So again, we need to tick one box. It is a 1 mark question. And these greenhouse gases, again, you need to know the greenhouse gases. They include obviously water vapor. They include carbon dioxide, which is in the question. They also include methane. So methane is a greenhouse gas. So remember, the 3 greenhouse gases are carbon dioxide, water, and methane. So let's have a look at our next question. Another calculation question. For this question, we need to calculate the relative formula mass of methane. And this is a question from quantitative chemistry. Remember, for paper 2, you can still be assessed on common content from paper 1. So you can still be assessed on atomic structure and the periodic table, on bonding, and of course on quantitative chemistry. So this is a good question to go through the evening before your exam. So what is the relative formula mass? Given that symbol MR, the relative formula mass of a substance is the sum of the relative atomic masses of the atoms in the numbers shown in the formula. So we can see that the chemical formula of methane is CH4. So there's 2 things we need to do to calculate the relative formula mass, the MR of any substance. We need to work out how many atoms of each element there are in the chemical formula. So you can see that we've got 1 carbon atom, and we've actually got 4 hydrogen atoms because we've got this little subscript number after hydrogen. So there's 4 hydrogen atoms. And then what we need to do is we need to look at our periodic table. We need to get the relative atomic mass of carbon and hydrogen, and then we need to add it all together. Now remember, tomorrow, please make sure that you have got a periodic table. And it should look something similar to this. If you're having a little bit of a moment, which we all do, especially in exams, you have a key. So look at the key if you forget which number is which. So the relative atomic mass is the top number. So we need to find carbon and we need to find hydrogen. So there is carbon. See if you can spot hydrogen. There we go. And there is hydrogen. So we can see that the relative atomic mass of carbon is 12. It's the top number. And the relative atomic mass of hydrogen, again, is 1. It is the top number. So let's go back to our question. So now we know that carbon's relative atomic mass is 12 and hydrogen's relative atomic mass is 1. Again, please make sure with any calculation that you do that you show your full workings out. Okay, so what would that look like then? So the relative formula mass of methane, oh, excuse me, a little cough there. So carbon has got a relative atomic mass of 12. There's only one carbon atom. And we've got 4 hydrogen atoms. So 4 times 1, so 12 plus 4 times 1, which is 4. So 12 plus 4 will give us a final answer of 16, again for 2 marks. Now, moving on to our next question. Greenhouse gases cause global climate change. Give 2 effects of global climate change for 2 marks. Now, the global climate has been changing since time began and it will continue to change in the future. Our planet's temperature has fluctuated in the last 100 years. However, though, since around the 1950s, there has been a dramatic increase in global temperatures. And this increase is known as global warming. Now, remember what global warming is, it's the rise in the average temperature of the Earth's surface. So, we need to give 2 effects of global climate change for 2 marks. So, rising sea levels, extremes of weather. So, for example, more severe and frequent storms. And I'm going to give you a little extra answer here as well. We only need to write down 2, but I'm just going to give you a little bonus answer. Loss of habitat. So, loss of habitat. So, habitat is a place where plants and animals live, and these can be lost. Okay, then. So, this question is still about the Earth's atmosphere, but thinking about the Earth's atmosphere today. And for about 200 million years, the proportions of different gases in the atmosphere have been much the same as they are today. So, about 4/5 of our atmosphere is nitrogen, 1/5 is oxygen, and then we've got small proportions of other gases including carbon dioxide and water vapor, and the noble gases, for example, like argon. So, all we need to do for this type of question is we just need to match up which part of the pie chart represents each gas in today's atmosphere. And this is a 3-mark question. So, based on our knowledge of the composition of our atmosphere today, remember oxygen is about 1/5, so 21%. Other gases, okay, so like carbon dioxide and water vapor, 0.1%. Nitrogen is about 4/5 of our atmosphere, so 78%. And then last but not least, argon, and which is a noble gas, is 0.9% of our atmosphere. So make sure you understand the composition of our atmosphere today. Okay, next question. Now, there is less carbon dioxide in the Earth's atmosphere now than there was in the Earth's early atmosphere, but it is increasing. Why are the carbon dioxide levels increasing in our Earth's atmosphere? Okay, and this is a 1-mark question. Well, it is due to our human activity on this planet. What we are doing is, we are burning fossil fuels. Why are we burning fossil fuels? Well, we are burning them to generate electricity, to heat our homes, for transport, and when we are burning fossil fuel, this releases carbon dioxide gas into the atmosphere. Okay, now moving on to this 4-mark question here. Carbon dioxide is a greenhouse gas. We need to describe the greenhouse effect, and this is a 4-mark question. So again, this command word, don't get mixed up with describe and explain. When you're asked to describe something, you may be asked to recall some facts, which is what we're going to be doing in a minute. It could be an event or a process in an accurate way. When you're explaining, you should make something clear and you should state the reasons for something happening. So this is a 4-mark question. So what is my top tip for this question? Well, again, you do have to be clear on the meanings of keywords. When you are asked about the greenhouse effect, you need to be answering this in terms of short and long wavelength radiation. Remember, a little bit of physics revision. The wavelength, you do need to know about wavelength in physics. The wavelength of any wave is the distance between two matching points on neighboring waves. So if you see the greenhouse effect, you're asking to describe this, you need to talk about this greenhouse effect in terms of short and long wavelength radiation. So what would that look like then? The short wavelength radiation from the sun passes through the atmosphere and is absorbed by the Earth's surface. The Earth's surface then emits longer wavelength infrared radiation. And this longer wavelength radiation is actually trapped by those greenhouse gases, by methane, by water vapor, by carbon dioxide. And this stops the radiation escaping from the atmosphere, so the temperature increases. Okay, so that is your 4-mark answer for this 4-mark question. So let's sum up. Remember, in chemistry paper 2, you will be expected to know and understand some basic concepts and principles from topics in paper 1. So we've got atomic structure and the periodic table, bonding, structure and the properties of matter, and quantitative chemistry. So to sum up, what are our question 3 top tips? Read all options in multiple choice carefully. Even if you are unsure of the correct answer, removing incorrect options can help you make a better decision. Take care with calculations and always show you're working out. Always be clear on the meanings of those keywords. Okay, so we have come to the end of our 3 questions, hopefully. Got lots and lots of tips from that to help support you tomorrow during your exam. Now, you have seen this before. I know this isn't your first science exam. You should be familiar now with what the paper looks like. Please, please make sure you have got the right tier. F for foundation tier, H for higher tier. If you're not sure, you've got the incorrect paper, pop your hand up and get the attention of one of the invigilators. They are there to help and support you. Okay. You do have a little bit of information at the beginning of the paper, so it tells you like the number of marks. It tells you those questions where you may have to use good English, so extended response questions. And don't forget as well, you've got your little grid to fill in. So please fill this in carefully. The centre number should be on the board at the front of the exam hall or the room that you're in. You should know your candidate number. It should be on a little card that's on your desk. And obviously, please, your surname, your forenames, and your candidate signature. Okay, so, and again, the most important thing, please make sure you've got your periodic table as well. During this part, I'll be sharing some exam-specific tips and advice on the screen. I'll also be responding to your last-minute questions throughout the session via the chat box. Please post your questions using the link in the chat. Okay, so the first thing that we are going to go through is the test for gases, and this always comes up. So I'm going to do test and result. Okay, so you need to know the test for hydrogen gas, which is H2, the test for oxygen gas, which is O2, the test for chlorine gas, which is Cl2, and then the test for carbon dioxide gas, which is CO2. So what you would do is, if you were doing the test for hydrogen gas, you would have some hydrochloric acid in a test tube. You pop a piece of magnesium in there, and that chemical reaction will produce hydrogen gas. And what you would do is you would get a burning splint. So you will need to have a Bunsen burner. You will have a wooden splint. You pop it into the Bunsen burner, so you set it alight, and then you would place that burning splint over the neck of the test tube that contains the chemical reaction that is producing hydrogen gas. And hydrogen gas will burn with a squeaky pop. You will hear a squeaky pop there. Okay, so the next test is for oxygen gas. So this time we don't use a burning splint, we use a glowing splint. Okay, so it's not burning, but it is glowing red. And if you put that glowing splint into a test tube that contains oxygen, that glowing splint will relight. So what is the test then for chlorine gas? You need to use damp litmus paper. Okay, so a little piece of litmus paper that's damp, so you put some water on the end of it. And what happens if chlorine gas is present, that litmus paper is bleached. And what that means is that it turns white. And then we've got the test for carbon dioxide, which is CO2. This time, we would bubble the gas through lime water. So to get the gas, you would react a metal carbonate like calcium carbonate with hydrochloric acid. You'd need 2 test tubes for this. You'd have a delivery tube, which will then bubble that carbon dioxide gas into lime water. Lime water is a colourless solution. And what happens when you bubble carbon dioxide into lime water? It turns milky or cloudy. So please make sure you are familiar with the test for gases for tomorrow. Okay, another question I would like to go through with you is the test for alkenes. This is another test that you need to know. This is a test that we use to determine the difference between an alkene and an alkane. So this is the test for alkenes. Alkenes are these small reactive molecules. They are hydrocarbons. Remember, hydrocarbons only contain hydrogen and carbon atoms, and they contain this carbon to carbon double bond, and they are reactive. So how can I test if I've got an alkene? Well, I would use bromine water. Now, bromine water is orange. And what the alkene does to the bromine water, it decolorizes it. Okay, make sure I check my spellings. So we will see a color change, and that color change will go from, the bromine water will go from orange to colorless. So the alkene, because it's a small reactive molecule, will basically decolorize that bromine water, and that's how we know whether we've got an alkene or an alkane, because alkanes don't react with bromine water. So if you add bromine water to an alkane, you give your test tube a shake to mix it up, then that bromine water will stay orange. It will only decolorize if you have got an alkene present, because that will react with the bromine water. Okay, another question is about reversible reactions. Okay, so what is a reversible reaction then? Most chemical reactions, they are irreversible, but some chemical reactions, they are reversible. So what does that mean? Well, reversible reactions can be represented by this symbol here. So this is the symbol that we use to represent a reversible reaction. So A and B will be my reactants, and C and D will be my products. So in a reversible reaction, A and B will react to form C and D. But then what will happen is that those products can then reform the reactants. Okay, so this is a chemical reaction that can go forwards and backwards. Okay, another question that I would like to go through with you is, let's have a look at doing some more relative formula mass calculations. Okay, now we went through how to calculate the relative formula mass of methane. Let's have a look at calculating the relative formula mass for carbon dioxide, which is CO2, and for water vapor, which is obviously H2O. So remember, linking into what we've done previously, carbon dioxide, water vapor, and methane, these are all greenhouse gases. So what you would do is you would need to remember, go back to your periodic table, look at that top number. Oops, if I draw what you would see on your periodic table for carbon, okay, that should be a C. So remember, it's the top number here. So that is the relative atomic mass. And that's what we would use to help calculate the relative formula mass. So carbon has got a relative atomic mass of 12. Oxygen has got a relative atomic mass of 16. Again, you're looking at your periodic table, looking at the top number. Hydrogen's got a relative atomic mass of 1. Okay, let's do carbon dioxide first of all. So CO2. So I've got 1 carbon atom. So its relative atomic mass of carbon is 12. I've got 2 oxygen atoms. So I need to do 2 times 16. Make sure you've got a calculator tomorrow. So 2 times 16 is 32. 32 plus 12 is 44. So we know that the relative formula mass of CO2, of carbon dioxide, is 44. Let's work out the relative formula mass of H2O. So I've got 2 hydrogen atoms. The relative atomic mass of hydrogen is 1. So 2 times 1. I've got 1 oxygen atom, and the relative atomic mass of oxygen is 16. So 2 times 1, which is 2, plus 16 is 18. Okay, so that, remember, that's how we calculate the relative formula mass. Okay then, so thank you all for joining us this evening. It's been a pleasure. We hope you're walking away more confident and better prepared for your exam tomorrow. Before we go, make sure to check the timetable in the chat so you can join our next live revision session. Your feedback helps us improve, so please take a moment to complete the pinned form in the chat. Don't forget to hit subscribe and turn on notifications so you never miss a session. A huge thanks once again for being part of this evening's revision. Remember, you've absolutely got this. Best of luck in your exams. We're rooting for you. Keep focused, stay motivated, and believe in what you've learned. We'll see you next time.